the last derivative rule we're looking at is the chain rule. Now the chain rule deals with composite functions. So we have d dx, the derivative with respect to x. So d dx of f of g of x. We looked at this back in chapter 1, composite functions. G of x is plugged into f of x. So what I like to do is I like to think of this in terms of inside and outside. So the function that is plugged in, I'm going to call that the inside function. The other one is the outside, and sometimes I'll refer to it as the overall function that we are looking at. So what we do is we take the derivative of the outside, but that function that was plugged in, we leave it alone for the time being. So the derivative of the outside, leave the inside alone. Then we multiply by the derivative of the inside. So there's a process to it. It's kind of like the product and the quotient rule. There's a formula, there's kind of a flow to it. You get your puzzle pieces, put your puzzle pieces together. So f prime of g of x times g prime. Take the derivative of the outside, leave the inside alone, multiply by the derivative of the inside. So let's take a look at this. Our first example here. We have f of x equals 4 times the square root of 5x minus 1. All right? Now, a lot of times it's helpful to identify your inside function first. Okay? So 5x minus 1, that is our inside function. That linear function, it got plugged in. Now what did it get plugged into? It got plugged into a square root function. So the square root function is the outside, or the overall. Overall, this is a square root function, but there's been a linear function plugged into it. That composite mixture there means we're doing a chain rule. So my advice is, just like we did with power rule, this square root, I'm going to rewrite this. So it's 4 quantity 5x minus 1 to the 1/2 power. Now you can do the puzzle pieces thing and put that together. I'll show you how that works with this one, okay? So we have f and we have g. Now remember, f needs to be your overall function. So g is the inside. So g is the inside. What got plugged in is 5x minus 1. So g is 5x minus 1. What did it get plugged into? It got plugged into a square root function that was also being multiplied by 4. So our overall is 4x to the 1/2. All right, that 5x minus 1 getting plugged in for the x would give us 5x minus 1 to the 1/2 power. So we pull that apart, get the inside and outside. So now let's take the derivative of each piece. So we need f prime, we need g prime. So power rule, 1/2 comes down, 1/2 times 4 is 2x, decrease your exponent by 1, negative 1/2. Right here, 5x minus 1, that just gives us 5. So now let's put our puzzle pieces back together. So f of x, now we need to start with f prime. F prime of g of x. So the of g of x is going to get plugged into f prime. So 2, the negative 1/2 power, 5x minus 1 gets plugged in. 5x minus 1, and then we multiply by g prime. G prime right here is 5. Multiply by 5. And there you have your chain rule answer. If you want, you can simplify this down. The 1/2 means it's a square root. The negative means it's in the denominator. 2 and 5 multiplied together would give you 10 in the top, and in the bottom, square root 5x minus 1. Either of those answers would work for that chain rule problem. So, getting your puzzle pieces, derivative of the outside, leave the inside alone, multiply by the derivative of the inside, and then simplify to your heart's content, okay? Example 2. Now let's take a look here. We have 3x squared times e to the 2x. Now what I want you to do is think about that language. 3x squared times e to the 2x. Okay? Overall, of all the derivative rules we're using, we have a quadratic and a natural exponential being multiplied together. So that means that this problem is going to require product rule, because we have two functions being multiplied together, product rule. Now, for this piece right here, 3x squared, that's going to be the power rule. E to the 2x. Now we have e to the 2x. That's different than e to the x. Okay, e to the x is just the natural exponential rule. E to the 2x, something else got plugged in. It's not just x, it's 2x. Something a little more complicated. Technically, that's a composite function, e to the 2x. If it's a composite function, means we are using chain rule. So another piece is going to require chain and e to the x. Multiple derivative rules happening at the same time, okay? So because it's product, I'm going to set up my puzzle pieces like I would. So f is 3x squared, g is e to the 2x. Now I'm going to get my puzzle pieces, f prime and g prime. Now f prime is pretty straightforward by this point. Power rule. Bring the 2 down, decrease the exponent by 1, get 6x. G, now that's going to require chain rule and e to the x. Now that 2x, that's the inside function. E overall is your outside. So let's work through that, okay? Derivative of the outside, leave the inside alone. Derivative of the outside, leave the inside alone. So look at the outside, e. What is the derivative of e to the x? Oh yeah, it's just e to the x. So the derivative of the outside is still just e. Then leave the inside alone. Don't do anything to it. So that 2x, leave it alone. Then multiply by the derivative of the inside. The derivative of 2x is 2. So we have all our puzzle pieces. We used power rule. We used chain rule. Now let's put all those puzzle pieces together to get our overall answer, f prime of x. So we're going to do this little cross thing right here. We have 3x squared. We have 2e to the 2x. And with product rule, we add. Do the other cross. E to the 2x and 6x. And you can leave that alone. Yeah, there is some factoring you could do. You could simplify this problem down, but it is not required at this time. So multiple rules happening. Overall, because we have a product, two functions being multiplied together, overall we have to use the product rule. But in that product rule, we have power, and we have chain, and e to the x. So you're using more than one derivative rule at a time. If we look down at example 3. Oh boy, this is good. Let's think about what's going on, okay? We have sine of x over 2x, all of it raised to the 4th. So think what derivative rule overall is happening, okay? You have a fraction inside parentheses raised to the 4th. Now when we talk through that, a fraction inside parentheses, and that inside is being raised to the 4th, that means we have a composite function going on. So overall, this problem is going to require chain rule because you have something being raised to the 4th. This got plugged in. Now what got plugged in? A fraction with a function in the top and a function in the bottom, a high function and a low function. So what got plugged in is going to require quotient rule. And in that quotient rule, we have trig and we have power. All that stuff happening, coming together at once, okay? So let's kind of talk through this one, because eventually you can kind of get the hang of these things where you can just kind of talk your way through them if you remember the process. So overall, the outside function is something raised to the fourth. So think of it as x to the fourth. Then that whole quotient is your inside, okay? So let's walk through chain rule. Derivative of the outside, something raised to the fourth. Let's take the derivative of that. Well, that's power rule. The 4 comes down, decrease the exponent by 1, and then leave the inside alone. So derivative of the outside, leave the inside alone. Outside was to the fourth, so the 4 comes down, decrease the exponent by 1, leave the inside alone. Then, chain rule says multiply by the derivative of the inside. Well, the inside is a quotient. In order to take the derivative of that, you need quotient rule. Low d high minus high d low over low squared. Low d high minus high d low over low squared. Let's work through that. Low d high. So the low function, 2x, d high, derivative of sine, is cosine. Minus high d low. Minus high d low. The high function, sine of x. Derivative of the low, derivative of 2x is 2. All over low squared. 2x squared. And there you go. A chain quotient trig power rule that when you start getting the hang of this stuff, you start remembering the process, you can talk your way through it. All right? Derivative of the outside, 4 comes down, 4 turns into a 3. Leave the inside alone. Multiply by the derivative of the inside. Quotient rule, low d high minus high d low, all over low squared.